In 1764, workers unearthed a massive skull near the Meuse River, too monstrous to be a fish, too alien to be a crocodile. Scientists argued for decades, unable to fit this creature into any known world. Its name, Mosasaurus, became a challenge to centuries of certainty, shattering assumptions about dinosaurs, extinction, and the limits of life in the ocean. But what they discovered next proved nothing about Mosasaurus was normal and rewrote scientific history forever. So how did one fossil trigger a revolution? In the late 1760s, deep beneath the limestone of Mount St. Peter, quarrymen struck something that defied every expectation. Embedded in the chalk, a colossal skull began to emerge, its jaws lined with unfamiliar recurved teeth, its shape unlike any creature known to science. The workers, accustomed to finding shells and fish bones, had no words for this monstrous head. Local records from 1764 and 1766 describe it as a marine oddity, sometimes labeled as a fish, sometimes as a crocodile, sometimes simply as the great animal of Maastricht. Adriaan Gilles Camper, a Dutch anatomist with a keen eye for the strange, took early interest. His notes, preserved in local archives, reveal both fascination and frustration. The skull's proportions and teeth didn't fit any living reptile or mammal. Camper saw hints of a giant lizard, yet the bones suggested a life spent in water. The fossil was cataloged and discussed in letters, but no one could agree on its true nature. Even the labels in the Taylor's Museum, where the first Maastricht skull would eventually reside, shifted over the years, from fish to crocodile to something entirely new. The name Mosasaurus would come later, inspired by the Meuse River that wound past the quarries. But in these early days, the fossil was less a scientific specimen than an enigma. Its very existence unsettled naturalists who still believed every creature had a living counterpart. As debates simmered, rumors spread of the fossil's value and power. Ownership became a point of pride and contention, drawing the attention of collectors, scholars, and soon nations. The skull was no longer just a curiosity in stone. It was a prize that threatened to upend the known order. In the chaos of 1794, as French revolutionary forces swept into Maastricht, the city's prized fossil was no longer just a curiosity. French officers acting on orders from Paris seized the massive skull from its Dutch keepers, labeling it a trophy of science alongside looted paintings and manuscripts. The fossil was crated and sent across war-torn Europe to the Muséum National d'Histoire Naturelle in Paris. There, it landed in the hands of Georges Cuvier, a rising force in the new science of comparative anatomy. Cuvier was relentless. Between 1798 and 1808, he dissected the skull's every feature, comparing its jaws and teeth to living crocodiles, lizards, and anything else the museum could provide. He found differences that could not be explained away. The jaw joint, the arrangement of the teeth, the sheer size, none matched any living animal. In his lectures, Cuvier argued that this was proof of something radical. The animal was extinct. It belonged to a world that no longer existed. At a time when most naturalists still clung to the idea that all creatures persisted somewhere on Earth, Cuvier used the Maastricht skull as his evidence that extinction was real. The fossil, once a local enigma, had become a weapon in a scientific revolution. It forced the world to consider that entire forms of life could vanish forever. As the fossil's reputation grew, so did its symbolic power, no longer just a relic, but a challenge to centuries of belief about the permanence of nature. When the first Mosasaurus skull finally arrived in Paris, its true scale became impossible to ignore. The bones alone suggested a creature that dwarfed anything living in the rivers or seas of Europe. Yet for years, scientists struggled to grasp just how immense this animal had been. Early estimates built from scattered bones and incomplete skeletons painted a picture of a large marine reptile, impressive, but not monstrous. That changed as more fossils surfaced. Skulls over 1.5 meters long began to appear in collections, some so massive that a grown man could lie alongside them and still not reach from jaw tip to jaw hinge. Modern researchers, armed with digital tools and comparative anatomy, set out to answer a simple question: how big was Mosasaurus really? Without a single perfectly preserved skeleton, they turned to three-dimensional volumetric modeling, piecing together data from dozens of specimens. By scaling up from the largest skulls and reconstructing the body outline, estimates for the biggest individuals reached over 15 meters, longer than a city bus, rivaling the length of a humpback whale. As for mass, the numbers are staggering. Depending on how thickly the body is reconstructed, a full-grown Mosasaurus could have weighed anywhere from 20 to 40 tons. That places it squarely in the weight class of modern whales, far beyond the size of any living reptile. Yet even these figures come with caveats. Every new fossil, every scan, every recalculated ratio adds nuance. Mosasaurus never fit neatly into expectations, not in life and not in the numbers. Its true scale remains a moving target, always just beyond the reach of certainty, but always greater than what came before. Mosasaurus was engineered for dominance in every sense. Its skull, a fortress of bone, supported a jaw system that defied convention. Instead of a single hinge, Mosasaurus possessed a double-jointed lower jaw, one main joint at the back, and a second flexible hinge halfway along the bone. This allowed each side of the jaw to flare outward, widening the gape and letting the animal engulf prey much larger than its head. Along the roof of the mouth, a second row of recurved teeth lined the pterygoid bones. These acted like backward-facing barbs, gripping flesh and dragging it deeper with each motion of the jaws. Once bitten, escape was nearly impossible. Modern biomechanical models, including finite element analyses, reveal that Mosasaurus combined flexibility with raw power. The arrangement of muscle scars and attachment sites behind the skull points to enormous jaw-closing muscles, comparable in scale to those of the largest living crocodiles. Estimated bite forces reach into the tens of thousands of newtons. This was a predator that could shatter bone and puncture armored shells, not just catch soft-bodied prey. But the jaws were only part of the equation. For decades, artists imagined Mosasaurus swimming with snake-like undulations. That view collapsed in 2013 when Dr. Johan Lindgren and his team published fossil evidence of a sharply downturned tail, preserved with a tall, crescent-shaped fin. Although this specimen belonged to a close relative, the implications were immediate. Mosasaurus, too, was built for high-speed pursuit, not slow cruising. Its stiff torso and powerful shark-like tail enabled sudden, explosive bursts, more than enough to overtake swift prey in open water. Every feature, from the double-hinged jaws to the tail fin, points to a single conclusion. Mosasaurus was purpose-built to rule as an apex predator, its anatomy tuned for domination in a world of giants. Across the western interior seaway, Mosasaurus stood alone at the top of the food chain. Fossilized stomach contents and bite-marked bones reveal a menu that spanned nearly every living thing in its world. Schools of fish, armored turtles, spiral-shelled ammonites, even seabirds. No prey was too tough or too swift. Remains of other marine reptiles, including plesiosaurs and large sharks, have been found bearing unmistakable Mosasaurus bite marks. In some cases, the only animal capable of leaving such wounds was another mosasaur. Evidence of cannibalism surfaces in bones scarred by the same recurved teeth that lined Mosasaurus's own jaws. In these warm, shallow seas, it hunted without rivals, its dominance written in the fossil record. The western interior seaway was its kingdom, a world where Mosasaurus preyed on everything, and nothing preyed on it. 66 million years ago, the world of Mosasaurus ended almost overnight. The asteroid impact that closed the Cretaceous set off a chain reaction. Sunlight vanished, plankton crashed, and the food web unraveled from the bottom up. In the fossil record, Mosasaurus vanishes at the same razor-thin boundary as the last dinosaurs. There is no drawn-out decline, no slow fade from dominance. One moment, the western interior seaway teemed with giants. The next, silence. Yet the story does not end in oblivion. In recent years, Dr. Michelle Everhart and her colleagues have uncovered a surprising diversity among mosasaurs. More than 10 distinct species, each adapted to a different niche. Bone histology reveals rapid growth, suggesting a metabolism far higher than anyone expected for a reptile of this size. Even in extinction, Mosasaurus continues to rewrite what scientists know about evolution and survival. Its abrupt disappearance remains one of the most striking signatures of the KPG boundary, a reminder that even the rulers of ancient seas were not immune to sudden catastrophe. Science still stumbles over creatures that break the rules. Each Mosasaurus fossil challenges what we think is possible, reminding us that nature's outliers often hold the real lessons. As the oceans change today, it's the unexpected survivors and their stories that could reshape our future. What do you think endures?